Good evening, and welcome to this video for 2017 Level 3 differentiation paper for Level 3 calculus. So question 1a, differentiate y equals the square root of x plus tan 2x. So for this question, we're going to rewrite square root of x as x to the power of 1/2, so we can differentiate easier. So y equals to x to the power of 1/2 plus tan of 2x. So to differentiate square root of x, we can just use the power rule. And to differentiate tan of 2x, we'll use the chain rule. So dy over dx equals to 1/2 times x to the power of negative 1/2 plus 2 times of secant squared 2x. For the tan 2x, tan differentiates to secant squared, and we need to multiply by the derivative of the inner function. So we need to multiply by the derivative of 2x, which is 2. So we multiply by 2, so we get plus 2 secant squared 2x, and we can tidy this one up a little bit. So dy over dx equals to 1 over 2 root x plus 2 secant squared 2x. And that's our final answer for this question. And just an achieve level question. So question B, find the gradient of the tangent of the curve y equals to e to the power of 2x over x plus 2 at the point where x equals 0. So we can differentiate y equals to e to the power of 2x over x plus 2 and substitute 0 to find the gradient at the point. So therefore dy, so we can, in this case, we can use the quotient rule because we have a function divided by another function. So we can say dy over dx equals to x plus 2 times of e to the power of, times by 2 e to the power of 2x minus 1 times of e to the power of 2x all over x plus 2 squared. So we substitute x equals to 0 to find the gradient. So dy over dx equals to 2 times of e to the power of 0 minus e to the power of 0 all over 4. So this should give us 4 minus 1 over 4, which gives us 3 over 4. And that's our final answer for this question, and this should just be another achieve level question. Question C, normal to the parabola y equals to 0.5 times x minus 3 to the power of 2 plus 2 at the point 1, 4, intersects the parabola again at point P. Find the x-coordinate of point P. So first thing we've got to do is got to find the equation of the normal. And if we make the equation of the normal equal to the equation of the parabola, we can find the 2 points of intersection, one of which will be point P. So we can find the x-coordinate of point P. To find the normal, we need to find the derivative of the function, and we need to find the gradient of the tangent. And by finding the gradient of the tangent, we can find the gradient of the normal. All right, so we have y equals to 1/2 of x minus 3 squared plus 2. So in this case, we can use the chain rule. Okay, so chain rule. So we can say dy over dx equals to, so we get 2 times 1/2 equals to 1. So it's x minus 3 to the power of 1 times by the derivative of the inner function. Derivative of x minus 3 is just 1. And the derivative of 2 is just 0. So dy over dx equals to x minus 3. And we're going to substitute the point 1, 4, because we know that that is where our normal intersects the parabola. Alright, so we can say that dy over dx equals to 1 minus 3, which equals to negative 2. So this is the gradient of the tangent. In order to find the gradient of the normal, we know that the gradient of the tangent times the gradient of the normal equals to negative 1. So gradient of tangent times gradient of normal equals to negative 1. Therefore, the gradient of the normal equals to negative 1 over negative 2, which equals to 1/2. So we can set up our linear equation. So that's y equals to mx plus c. Y equals to mx plus c, and we know that m equals to 1/2, so that's our gradient. Y equals to half of x plus c, and we know that it will intersect the parabola at 1, 4. So therefore, we can substitute that point in. So we can say 4 equals to 1/2 times of 1 plus c. Therefore, c equals to 7 over 2. So now we can say y equals to 1/2 of x plus 7 over 2. And we can make this one equal to the equation of the parabola to find the other point P. So therefore, half of x plus 7 over 2 equals to 1/2 of x minus 3 squared plus of 2. So therefore, 1/2 of x plus 7 over 2 equals to 1/2 of x squared minus 6x plus 9 plus 2. Therefore, 1 half of x plus 7 over 2 equals to 1 half of x squared minus 3x plus 9 over 2 plus 2. So therefore 0 equals 2. If we move everything to the move everything to the right hand side, we'll get 1 half of x squared minus 5 over 2x plus of 9 over 2 minus 7 over 2 plus 2, which is 3. Alright. So now we just need to plug this into our graphics calculator. So 1 half, 2, 3. So you should get that. You should get 3 and 2. Do something wrong. Sorry. 9 over 2. 2 minus 2, 3 minus 1. Alright, I apologize, I just made a mistake. So 1 half of x, so negative 3 minus 1 half is negative 7 over 2. I apologize for that one. So that's the mistake, so I apologize. So 1 half negative 7 over 2, 3. So we should get x equals to 6 or x equals to 1. But we know that x equals to 1 is the coordinate that they originally gave to us. So that's not our answer. So therefore x coordinate of p is equals to 6, okay? And that should be our final answer for this question. And this should be a merit level question. You can find our final answer. To get a merit, you probably need to be able to find the gradient of the normal. To find the gradient of the normal, you'll get an achieved. Question D. A curve is defined parametrically by the equations x equals to square root of x plus 1 and y equals to sine of 2t. Find the gradient of the tangent of a curve at the point when t equals to 0. So in this equation, we have x in terms of a variable t and y in terms of a variable t. So if we can find the relationship between the derivatives of x and y, we can find dy over dx. So parametrically, we know that dy over dx equals to dt over dx. So dt over dx multiplied by dy dt. Alright, so to differentiate x equals to square root of t plus 1, so we say x equals to t plus of 1 to the power of 1 half, and we can use the chain rule in order to differentiate. So dx over dt equals to 1 half of t plus of 1 to the power of negative 1 half times of the derivative of t plus 1, which is just 1. So therefore dx over dt, if we tidy this one up a little bit, we get 1 over square root of 2 plus 2 square root of t plus of 1. In terms of differentiating sine of 2t, so we say dy over dt equals to 2 cos of 2t, because sine differentiates to cos, and we need to differentiate by the derivative of the inner function. So the derivative of 2t is 2, so we multiply by 2. So in this case, dt over dx will just be the inverse, which is inverse of 1 over 2 times t square root of t plus 1. So this gives us 2 times square root of t plus of 1. So therefore dy over dy over dx, apologize. Dy over dx equals to 2 cos of 2t multiplied by 2 square root of t plus of 1 all over 1. So therefore we want to find the tangent, the gradient of the tangent at t equals 0. So we just substitute t equals 0 into our equation. So dy over dx equals to 2 cos of 0 times of 2 square root of 1. Alright, so cos of 0 gives us 1. So this gives us 2 multiplied by 2 square root of 1. Square root of 1 is still just 1, so therefore it's 2 times of 2 basically. So that gives us a final answer of 4. That should be our final answer for this question, which should just, again, it should be a merit level question. Merit level for the final answer. In terms of getting an achieved, we need dx over dt or dy over dt, just any of those ones. So this one or this one will get you an achieved. Okay, looking at question E, find the values of a and b such as the curve y equals to ax minus b over x squared minus 1 has a turning point at 3, 1. Alright, so we know that the curve of y equals to ax minus b over x squared minus 1 has a turning point at 3, 1. Turning point means gradient equals to 0. It means that it's a stationary point. So therefore, if we take dy over dx, we know that equals to, so we know that dy over dx equals to 0 when x equals to 3. And because we know that it passes through the point 3, 1, we know that when y equals to 1, when y equals to 1, x equals to 3. So first things first, we can actually get our first equation straight away by substituting the point 3, 1 into our curve. So therefore, we can say 1 equals, red pen. So we can say that 1 equals to 3a minus b over x squared, in this case, is 9 over 8. 3 squared is 9, 9 minus 1 is 8. So 1 equals to 3a minus b, so therefore 8 equals to 3a minus b. That's our equation number 1. Alright, in order to find our gradient function, we need to differentiate the dy over dx. That equals 2. So in this case, we have something divided by something else. So we're going to be using the quotient rule. Okay, so the quotient rule. So in this case, it's going to be x squared minus 1 multiplied by derivative of x minus b, which is just a, minus the derivative of x squared minus 1 is just 2x multiplied by ax minus b all over x squared minus 1 to the power of 2. So therefore, dy over dx is equals to ax squared minus a minus 2ax squared plus of 2bx all over x squared minus 1 squared. So we know that dy over dx equals to 0 when x equals to 3. So therefore, 0 equals to a times of 3 squared minus a minus 2a times of 3 squared plus 2b times of 3. Alright, so if we simplify this a little bit, we'll get 0 equals to 9a minus 3 squared is 9 minus 18a plus of 6b. So therefore, 0 equals to negative 10a plus 6b. So now we have our two equations. We have 8 equals to 3a minus b, and we have negative 10a plus 6b equals to 0. So therefore, we can actually just, in this case, we could just use our graphics calculator. So we can go to the simultaneous section of the calculator. You can find what a and b is. So for this question, we can find. Alright, so in this case, we should come to our answers that a equals to 6 and b equals to 10 as our final answers for this question. So a equals to 6 and b equals to 10, and that should give us our excellence grade. To get a merit grade, we need to find a correct derivative plus one of the two equations rating a and b. So if we can find dy over dx, and we also find this equation here, or by finding any one of those two equations will get you a merit. To get an achieved, you need just the correct derivative here will get you an achieved. Alright, so looking at question 2, differentiate y equals to 2 times of x squared minus 4x to the power 5. So in this case, this is a very common just chain rule question. So we're going to say dy over dx equals to 5 times of 2, which is 10, multiplied by x squared minus 4x. Take the power down by 1. 5 minus 1 is 4. Multiplied by the derivative of the inner function, which in this case is 2x minus 4. And we don't need to simplify our answer, so we can just leave our answer like this, and that will be enough for an achieved grade. Question B. The percentage of seeds germinating depends on the amount of water applied to the seedbed that the seed is sown in, and may be modeled by the function P of W equals to 96 ln of W plus 1.25 minus 16W minus 12, where P is the percentage of seeds that germinate and W is the daily amount of water applied. So that's liters per square meter of seedbed, where W is between 0 and 15. Find the amount of water that should be applied to maximize the percentage of seeds germinating. So whenever we see maximize or minimize, we know we have to differentiate and make equal to 0, because at the maximum or minimum, the turning point is a turning point, therefore it's a stationary point, and therefore the gradient is equal to 0. Therefore, you make the gradient function equal to 0. So we just need to differentiate this function. That's the first thing we need to be doing. So P dash of W equals to 96 derivative of ln of W plus 1.25, that's just times of 1 over W plus of 1.25 multiplied by the derivative of the inner function, which is w plus 1.25. But if you differentiate that, you just get 1. So anything multiplied by 1 is still just that number. So therefore, that gives us 96 over w plus 1.25. And the derivative of negative 16w is just negative 16. And the derivative of negative 12 is 0. So now we need to make this equal to 0. So therefore, 0 equals to 96 multiplied by 1 over w plus 1.25 minus 16. So therefore, we should get that 16 equals to 96 over w plus 1.25. So therefore, 16 times w plus 1.25 equals to 96. If we expand, we'll get 16w plus 16 times 1.25. So 16w plus 20 equals to 96. Therefore, 16w equals to 76. And that should give us w equals to 6, if I'm not mistaken. Okay, sorry, I apologize. It's actually w equals to 4.75. Apologize. So w equals to 4.75. So we need to find the amount of water that should be applied. So we can just say w equals to 4.75. And therefore, 4.5 liters per square meter of seabed should be applied. So therefore, 4.75 liters per square meter should be applied. Alright, and that's our final answer for that question. Okay, so that's w equals to 4.75. That is our answer, and that's just an achieved level grade. Question C. The tangent of a curve y equals to root x is drawn at the point 4, 2. Find the coordinates of the point Q where the tangent intersects the x-axis. So in this case, we just need to differentiate and then find the equation of the tangent and make equal to 0. So, make x equals to 0 in order to find our y-intercept. So basically, it's just telling us to find our c value. So in this case, y equals to square root of x. So therefore, dy over dx, that should give us 1/2 of x to the power of negative 1/2, which equals to 1 over 2 root of x. In this case, if we want to find the gradient of the tangent, we need to substitute the point 4, 2. But in this case, we're going to be substituting the x point, which is 4. So therefore, dy over dx equals to 1 over 2 root 4. And that should give us 1 over 2 times of 2, which gives us 1 over 4. So therefore, we can write our equation of the tangent. So y equals to mx plus c. Therefore, y equals to a quarter x plus of c. And we also know that this point that intersects the tangent intersects the curve is 4, 2. We're going to substitute that point in order to find our c value. So y equals to 1/4 multiplied by our x point, which is 4, plus of c. But in this case, our y is equal to 2. So in this case, 2 equals to 1 plus c, and therefore c equals to 1. Y equals to 1/4 x plus of 1. So therefore, we can say that the y-intercept equals to 1. And that should be our final answer for this question, okay? In terms of finding point Q, that's the x-axis. I apologize. So that's not our y-intercept. I apologize. That's actually our x-intercept. So our x-intercept can be found by making y equals to 0. So therefore, 0 equals to 1/4 x plus 1. Negative 1 equals to 1/4 x, and therefore x equals to negative 4. X equals to negative 4. So x equals to negative 4, we know that it's the x-intercept, so the y is 0, so therefore the point would be negative 4, 0. And that should be our final answer for this question. So if you can get the final answer here, you'll get a merit grade. To get an achieved grade, you need a correct derivative. So correct derivative right here, that'll get you an achieved. For question D, find the coordinates of the point P, x, y on the curve y equals to square root of x that is closest to the point 4, 0. You do not need to prove that your solution is the minimum value. So in this case, we can actually see that this is just simply a right angle triangle in terms of the distance. So we know that this distance here, we'll call this distance D. And we'll say that this here, this will be our some x value, so we don't know what x is, but that's some x value, and this is some y value, okay? We know that a y value is simply found by substituting the y value, by substituting that x value into the equation y equals the square root of x, and we know that this x value can be found by using 4 minus whatever this x is. We know that this here is, sorry. So we know that this length Alright, so we know that from this point to point P, we can call it x, and therefore this little blue x here, that would be equal to 4 minus x. So that's a small distance, is equal to 4 minus x, and we know that y is equal to square root of x. Okay, so because that's our y point and therefore our curve. So therefore x squared plus, we use a black pen, so x squared plus y squared equals to d squared. D equals to square root of x squared plus of y squared. So therefore d equals to square root of x, we know is 4 minus x squared plus of y squared. So in this case is y squared is square root of x squared. Therefore d equals to square root of x squared minus 8x plus 16 plus of x squared. So therefore d equals to square root of 2x squared minus 8x plus 16. And in order to find the minimum, we need to differentiate and make equal to 0. So in this case, we can say d over dx equals to, well, we can say that this, first we can rewrite this as 2x squared minus 8x plus 16 to the power of 1 half, and we can apply the chain rule, okay? So in this case, we get 1 half of 2x squared minus 8x plus 16 to the power of negative 1 half multiplied by the derivative of the inner function, which in this case is 4x minus 8. So in this case, we can say that dd over dx, so dd over dx equals to 2x minus 4 over square root of 2x squared minus 8x plus 16. We need to make it equal to 0. The reason we need to make it equal to 0 is because it's the minimum. So at minimum, dd over dx equals to 0. So in this case, 2x minus 4 equals to 0. We'll get that x equals to 2. Alright, so alright, okay, I see. Sorry, I apologize, I've made another mistake. It appears, sorry, I apologize for that one. Okay. So the mistake was that so square root of x squared is actually just x, it isn't x squared. So that's my mistake there, so I apologize. So square root of x squared is x, not x squared. So d equals to square root of x squared, in this case minus 7x plus 16. Right, that's right. So dd over dx equals to 1 half of x squared minus 7x plus 16 to the power of negative 1 half times 2x minus 7. Alright, so in this case we have dd over dx equals to 2x minus 7 over square root of x squared minus 7x plus 16, and we need to make it equal to 0. So dd over dx equals to 0. So therefore 2x minus 7 equals to 0, and therefore 2x equals to 7, and x equals to 7 over 2. So 7 over 2 is our x coordinate, and if we substitute that into our y, so we can say y equals to square root of x, which is square root of 7 over 2. So in this case, we can say that the coordinates of p would be 3.5 and square root of 7 over 2. We can just leave our answer like this, so that's square root of, so 3.5 square root of 3.5 basically. So 3.5 square root of 3.5. And that's our final answer for this question, which should be a merit level question. To get an achieved, you need to find a correct expression for dd over dx. So dd over dx, if you can get correct expression for that one, you can get an achieved. Alright, so apologies for getting it wrong the first time. I had a little bit mind blank. So square root of x squared is x, not x squared, okay? It is quite a common mistake because you see the squared and you automatically think x squared. So I apologize for that one. But moving on to the next question. Question E. A rectangle is inscribed in a semicircle of radius r as shown below. Shown that the maximum possible area of such a rectangle occurs when x equals to r over square root of 2. Alright, so this equation, we need to write down what the area of the rectangle is, which in this case is a equals to base times of height. Alright, so we know that the base is equal to negative x, 0 to negative x is x, and 0 to x is x. So x plus x is 2x. So a is equal to 2x times we'll call this y. So a equals to 2xy, and we don't know what y is. So in order to solve this question, we need to find an equation of y in terms of x. So we can substitute y in terms of x into our equation, and we can find we can find basically when we differentiate, we can make equal to 0 and find x in terms of r. So one thing we can note here is that if we draw a line from the middle point to the corner of the rectangle, that will be equal to r, because that is the radius of the semicircle. Because any point drawn from the middle to the circumference is the radius, and we know that that is equal to r because that's the radius of the semicircle. So in this case, we can very clearly make up an equation using our Pythagoras theorem that x squared plus y squared equals to r squared. And therefore, y squared equals to r squared minus x squared. And if we make y the subject, we can say y equals to square root of r squared minus x squared. Alright, so now we got exactly what we wanted, because we have an equation for y in terms of x. The reason it's y in terms of x is because we know that r is a constant, okay? R is a constant because the radius of the semicircle is staying the same. So therefore, a equals to 2x times the square root of r squared minus x squared. In order to find the maximum error, we need to differentiate with respect to x. The reason we differentiate with respect to x and not with respect to r is because r is a constant, it's not changing. But for x, we can change x in order to find and observe how it changes the area of the rectangle. So because we're trying to observe the changing x, the x is the changing variable, we're going to differentiate with respect to x. So therefore, dA over dx, we're going to be using the product rule as well as the chain rule. So the product rule has to be used because we have 2x, that is a function of x, multiplied by square root of r squared minus x squared, that's also a function of x. So two functions of x multiplied together, we're using the the product rule. So dA of dx equals to square root of 2, not square root, so differentiation of 2x is just 2. So this equals to 2 times square root of r squared minus x squared, plus 2x times the derivative of r squared minus x squared. Alright, so we have times of 1/2 of r squared minus x squared to the power of negative 1/2 times the derivative of the inner function, which is negative 2x. Alright, so therefore dA over dx equals to 2 square root of r squared minus x squared. And we have plus 2x multiplied by negative x over square root of r squared minus x squared. Let me just double check that one. So 1/2 times negative 2x is just negative x at the top, and r squared minus x squared to the power of negative 1/2 is equal to 1 over square root of r squared minus x squared, so that's right. So therefore dA over dx equals to 2 square root of r squared minus x squared plus of negative 2x squared over square root of r squared minus x squared. Alright, so now we have to make everything equal to 0, because at a maximum, the gradient function equals to 0. So therefore 0 equals to 2 square root of r squared minus x squared minus 2x squared over square root of r squared minus x squared. And we can move negative 2x squared over square root of r squared minus x squared to the other side. So 2x squared over square root of r squared minus x squared equals to 2 square root of r squared minus x squared. Alright, so we can move square root of r squared minus x squared times that by on both sides. So we have 2x squared equals to 2 times of r squared minus x squared. And therefore 2x squared equals to 2r squared minus 2x squared. Therefore, if we simplify this a bit further, we'll get 4x squared equals to 2r squared. And if we divide by 2 on both sides, we'll get 2x squared equals to r squared. Therefore, x squared equals to r squared over 2. And therefore, x equals to square root of r squared over 2 plus or minus. And therefore, x equals to r over root 2 plus or minus. But since x is greater than, we'll say it's greater than 0, therefore x equals to r over square root of 2, which is our final answer, and which is what we have here. So that's a QED, we are done. And therefore this is an excellence level question, so we can get up to an excellence grade for this question. So correct final answer here is an excellence. To get a merit, you need a correct derivative. So correct derivative will get you a merit. So correct derivative up to here will get you a merit, and there's actually no criteria for an achieved, so you can either get achieved or, you can either get merit or excellence for this question, but not achieved. Question 3, differentiate y equals to x ln of 3x minus 1. So in this case, we have a function of x and another function of x multiplied together, so we've got to use the product rule. So therefore dy over so in this case, we have dy over dx equals to, derivative of x is just 1, so 1 times ln of 3x minus 1 is just ln of 3x minus 1, and plus of x multiplied by the derivative of ln of 3x minus 1, which is 1 over 3x minus 1 times of the derivative of the inner function. Derivative of 3x minus 1 is 3, so multiply by 3. So therefore dy over dx equals to ln of 3x minus 1 plus of 3x over 3x minus 1. And that should be our final answer for that question. So we have a correct derivative for an achieved. Question B, find the gradient of the curve y equals to 1 over x minus 1 over x squared at the point 2, 1/4. Alright, so in this case, we just have to find the derivative and substitute x equals to 2 to find the gradient. So dy, oh, red pen again, sorry guys. So dy over dx equals to negative 1 over x squared. Actually, okay, I'll show you how. Actually, we can start off by making this a bit easier. So y equals to x power of negative 1 minus x power of negative 2. Alright, so now we just need to use the power rule. So dy over dx equals to, so negative 1, bring it down to negative 1 times of x to the power of negative 2. And in terms of differentiating negative x to the power of negative 2, so negative 2 times negative 1 is just plus of 2. And we need to take the power down by 1, so this becomes x to the power of negative 3. So therefore dy over dx equals to negative 1 over x squared plus 2 over x cubed. So now I substitute x equals to 2 to find the gradient at the point. So dy over dx equals to negative 1 over x squared, which is 4, plus 2 over 2 cubed, which is 8. So negative 1/4 plus 2 over 8, that's actually just 0. So this gives us 0, and that should be our final answer. So this is, again, it's just an achieved level question. Question C, the graph below shows the function y equals to f of x. So for the function above, find the values of x that meet the following conditions. F dash of x equals to 0, so that's our gradient function equals to 0, so that's our stationary point, so that's our flat line. So as you can see here, for the parabola, we have our stationary point here. So that's that's a turning point, so our gradient equals to 0, so this is our f dash of x equals to 0. And as well as the straight line here, the straight line here is horizontal, therefore here f dash of x also equals to 0. So in terms of the boundaries, we can just say that x equals to 2 and x is less than negative 2. And it's less than negative 2 because we see this arrow, it means it's continuous forever. So question 2, f of x is continuous but not differentiable. So when it's continuous but not differentiable, that's our sharp corners, okay? We cannot differentiate at sharp corners, therefore that would be our not differentiable. They're continuous places, but they're not differentiable. So as you can see here, there is a sharp corner here and a sharp corner here. So those are our 2 points. So x equals to negative 2 and x equals to 1. Question 3, f of x is not continuous. Okay, so when f of x is not continuous, that means there is a break in the graph. So in this case, that occurs at x equals to negative 1. That's here. And that's because for here, we have a solid dot and a white dot. So in this case, the value of f of x at f equals to negative 1 is actually 1, not 2. It's because the value is at the black dot, not the white dot, and hence this is not continuous. This also happens at x equals to 0, and as you can see here, the value of f of x at x equals to 0 equals to 3. So therefore, we're going to have x equals to negative 1 and x equals to 0. Alright, so for question 4, the second derivative is less than 0, so that's our concave down. So whenever I see concave down, so whenever you see less than 0, you can think of it as a sad parabola, because whenever you see this concave down, you'll see the sad frowning shape, okay? It's easier way to explain it. So as you can see here, we have this parabola and it's concave down, and we can know it's concave down, and we know that if the second derivative is less than 0 because we see that it's a curving downwards, and it makes a sad face, okay? So if I put two eyes here, as you see here, it's going to make a sad face. So whenever you're looking at concave down, just look for a sad face. Whenever you're looking for concave up, you're looking for the opposite way around. So you're looking for this happy face here. That would be concave up, okay? Alright, so in this case, we're going to be finding the boundaries for this parabola. The boundaries for the parabola is just x is greater than 1. It's because this parabola goes on forever after x equals to 3. So in this case, this is just simply x is greater than 1. Question II, so what is the value of f of x as x approaches to -1? So as x approaches to -1, the f of x actually approaches positive 2. Even though the actual value of f of x at x equals to -1 equals to 1, the graph is actually approaching, y equals to 2, because both sides of the graph are both approaching 2, y equals to 2. As you can see here, the right hand side is approaching 2, y equals to 2, and the left hand side here is also approaching 2, y equals to 2. So therefore the limit is just 2. Alright, so to get a merit grade for this question, you need to have 3 correct answers. So 3 out of 5 will get you a merit grade, which is actually pretty lenient, but that's how it is. And for an achieved grade, just 2 out of 5 will get you a achieved. Question D. A building has an external elevator. The elevator is rising at a constant rate of 2 meters per second. Sarah is stationary, watching the elevator from a point 30 meters away from the base of the elevator shaft. Let the angle of elevation of the elevator floor from Sarah's eye be theta. Find the rate at which the angle of elevation is increasing when the elevator floor is 20 meters above Sarah's eye level. So in this case, we know the elevator is rising at a constant rate of 2 meters per second. So we're going to let this, let's just say this distance of the elevator, we'll let it be x. So say this equals to x. So therefore, we can write down our rate of change. So dx over dt equals to 2. And we're trying to find d theta over dt. So d theta over dt is what we're trying to find, because we're trying to find the rate of change of the angle of elevation. So we can write what we need. So d theta over dt equals to dx over dt multiplied by dx over d theta. So we're looking for d theta over dx. So d theta over dx means we need an equation for x in terms of theta, or we need an equation for theta in terms of x. So that's actually very simple, because we can simply say that tan of theta equals to x over 30. So tan theta equals to x over, so tan theta equals to x over 30. And in this case, we can actually make x a subject, so x equals to 30 tan theta. And therefore dx over d theta, that equals to 30 sec squared theta. Because tan differentiates to sec squared, and therefore we have 30 sec squared theta. In order to find d theta over dx, we need to find the inverse, but we also know that sec squared theta equals to 1 over cos squared theta. So this equals to 30 over cos squared theta. To find d theta over dx, we just need to find the inverse, which is flipping the fraction, which is, this is 1 over 30 multiplied by cos squared theta. Alright, so now we have both our related rate of change, so we can find d theta over dt. So d theta over dt equals to 2 multiplied by cos squared theta over 30. Therefore, d theta over dt equals to 1 over 15 times cos squared theta. So we need to find the angle, the rate of change of the elevation angle when the elevator floor is 20 meters above Sarah's eye level. So we need to find the angle when x equals to 20. The reason we need to find the angle when x equals to 20 is because we have d theta over dt in terms of theta. So we need to find our value of theta when x equals to 20. So therefore tan of theta equals to 20 over 30. Therefore theta equals to tan inverse of 2 over 3. Tan inverse of 2. Okay, so that's about 0.588 radians. So remember, when you're doing these types of questions, it's always in radians. Alright, so d theta over dt, this equals to cos squared of 0.588 over 15. Alright, this should give us an answer of 0.0462 radians per second. And that should be our final answer for this question. Okay, so 0.0462 radians per second, that'll get you a merit grade. To get an achieved grade, you need a correct expression for dH over d theta. In this case, we used x, which is totally fine as well. So correct expression for dH over d theta, or in our case, dx over d theta. So dx over d theta, so getting it up to here, that will get you an achieved. Alright, so question E. For the function y equals to e to the power of x cos kx, find dy over dx and d squared y over dx squared. So find the first derivative and find the second derivative. So the first derivative we can find using the product rule. So that's dy over dx, that equals the derivative of e to the power of x times cos of kx. But the derivative of e to the power of x, that's still e to the power of x. So dy over dx equals to e to the power of x cos of kx plus of the derivative of cos kx times e to the power of x. So plus e to the power of x multiplied by the derivative of cos of kx, which in this case is negative k sine of kx. So cos differentiates to negative sine, and we need to multiply by the derivative of the inner function. Derivative of kx is just k. So therefore dy over dx equals to e to the power of x cos of kx minus ke to the power of x sine of kx. Alright, so for our second derivative, so d squared y over dx squared. This equals the derivative of e to the power of x cos of kx, which in this case is just the same as what we had originally. So this will just be e to the power of x cos of kx minus e to the power of k e to the power of x sine of kx. Alright, so derivative of negative k e to the power of x sine kx, we need to use the product rule again. So derivative of e to the power of x, that's still e to the power of x, so that will still be negative k e to the power of x sine of kx. And we need to find the derivative of sine kx multiplied by negative k e to the power of x. Derivative of sine kx is k cos kx, because sine differentiates to cos, and we need to multiply by the derivative of the inner function, which is k. So in this case, we'll have minus k squared e to the power of x cos of kx. And that's our final answer for this question. Okay, so this question. Alright, so question 1 and question 2 are just combined, so we'll do question 2 first. So find all the values of k, such as the function y equals to e to the power of x cos kx satisfies the equation. So the second derivative minus 2 times the first derivative plus 2 times of y equals to 0. Alright, so the second derivative is simply just, or we can actually simplify the second derivative a little bit more. So we have e to the power of x. So e to the power of x cos of kx minus 2k e to the power of x sine of kx minus k squared e to the power of x cos of kx. Alright, so in this case, we're just going to substitute our values in, and we're going to find possible values for k that can make this equation true. So therefore, e to the power of x cos of kx minus 2k e to the power of x sine of kx minus k squared e to the power of x cos of kx minus 2 times of dy over dx, which was e to the power of x cos of kx minus k e to the power of x sine of kx. And we need to add 2 times of our original function, which was e to the power of x cos of kx. And that equals to 0. Alright? Okay, so in this case, we have a little bit of simplifying to do. So in this case, we have e to the power of x cos of kx minus 2k e to the power of x sine kx. So minus 2e to the power of 2e to the power of x cos of kx plus of 2k e to the power of x sine of kx plus 2e to the power of x cos of kx. Alright, so in this case, that equals 0. Alright, so in this case, we have negative 2k e to the power of x sine kx, and that's going to cancel out with this positive one here. So negative 2k e to the power of x sine kx plus 2k e to the power of x sine kx equals 0, so that cancels out. Alright, so we also have 2e to the power of x cos of kx cancelled out with negative 2e to the power of x cos of kx, so those two cancel out. So all we're left with now, I apologize. So all we're left with now is e to the power of x cos of kx minus k squared e to the power of x cos of kx. So this gives us e to the power of x cos of kx minus k squared e to the power of x cos of kx equals 0. And we can factor out e to the power of x. So e to the power of x cos of kx minus k squared cos of kx equals 0. Alright, so we can actually further factorize this a bit more. So we can say cos of x, so e to the power of x cos of x multiplied by 1 minus k squared equals 0. But we know that e to the power of x cannot be equal to 0. And we know that cos of x, we're trying to find the equations of, not equations. Okay, so we're trying to find the values of k such as the function satisfies the equation. So it has nothing to do with x, so we can say that e to the power of x cos of x, we can just ignore it. So therefore 1 minus k squared equals to 0, and therefore 1 equals to k squared, and therefore k equals to plus or minus 1. And k equals to plus or minus 1, that should be our final answer, and that should give us an excellence level grade. To get a merit level grade, you need a correct expression for the second derivative. So you can get the second derivative correct, that will get you a merit grade. To get an achieved grade, you need a correct expression for dy over dx. So in this case, you'll get an achieved grade for the correct derivative of dy over dx. Alright, so thank you for watching this video for the 2017 Level 3 differentiation paper. I hope you enjoyed watching, and I hope to see you all in the next video.